today we are fortunate to have Professor Ye here to have an interview. And Professor Ye comes from Technical Institute of Physics and Chemical CAS. Good afternoon, Professor Ye. It's very nice to see you. Firstly, would you please briefly introduce your research group and the research you are focusing on currently to us?
Okay, thank you. First, I'm so honored to be invited here to as a guest for Zolik. It's also very many thanks to Chen, and I'm so happy to be here. And first, let me introduce a little about myself and Chen Ye, a professor from Chinese Academy of Science, and I'm now doing a photochemical conversion. And my major work or major study research investigation is about to use different kinds of spectroscopy skills, instrument or techniques to uncover the mechanism of different type of photochemical conversions.
Thank you. For the ultra-fast spectroscopy you have mentioned, what breakthroughs can this technology bring to you when you try to understand the transient species in photochemical reactions?
Yeah. Normally, first let me introduce a little about why we use ultra-fast spectroscopy in our study.
Yeah.
And we are doing different kinds of light-driven reactions. Like you use light to convert different kinds of water into hydrogen, which is kind of a energy fuel. And also we try to discover how our life, the natural the system, they use light, they harvest the light to produce different kind of stuff. But doing this kind of research, you need to know how this reaction works. So the most powerful tools we use is different kinds of time-resolved spectroscope, especially ultra-fast, since we need a very short this kind of time resolution to see how this transient species works during the processes.
Yeah.
So ultra-fast spectroscopy can help us to capture these very short-lived species during the reaction, and we could use this information to figure out how the reaction networks flow. And now for doing this kind of research, some kind of challenges we need to try to keep this kind of instrument with a very high resolution, and especially on the resolution of this time resolution and also the spectrum time resolution. So with this kind of help, and we also need to handle a lot of data. Every time when we do a spectroscopy experiment, we have to handle huge amount of data. For doing this kind of data, we need to to generate some advanced and analytical tools to increase the reliability of our result, and try to figure out what's the most important and what's the most powerful information hidden in the big amount of data.
Yeah, so for the data processing you have mentioned, I think the data interpretation and signal-to-noise ratio are very important for ultra-fast spectroscopy. So what's the challenge do you face when you're processing this data?
It's a very good question. It reminds me of about 10 to 20 years ago, and during that time we use this kind of a simple. We are treating these simple models and a simple problem. So at that moment, the data we need to process is just like a small amount of data. You can directly use some very simple ways and we have to see during that time the computer skills are not developed as now. But now for each single experiment, we have to treat like a gigabyte data. So that's a huge amount of data, and most of this data are composed of actually they are composed of noise, and the real important information are hidden inside. So recently, for the recent several years, we are trying to devote ourselves to develop some advanced techniques, especially involved with mathematics, like machine learning algorithm or this kind of advanced signal processing techniques. We use this kind of stuff to help us to improve the quality of our data analysis, and we want to use this. We also want to promote this kind of research or our analytical result to the different to our friends or our partners and all the people are doing this same type of research.
Yeah, that's amazing.
Thank you.
As for the demands of the photochemical research are various. So what do you think? How can Zolix help you in your research?
Yeah. So here I want to how do I say? I want to give a advertisement, but it's based on my personal feeling and I have a long term this partner relationship with Zolix. So this kind of something I'm not boosting Zolix, and it's kind of like a truth from my personal view. I would say Zolix they provide a comprehensive a variety of this kind of solutions, so which can including different type of instrument like laser and detectors and also the optical system, but and at the same time they also provide important this kind of the analytical solutions, like how we can convert how we involve different type of instrument and then try to help us to figure out what we want to get from these practical problems. So both this solid instrument and this kind of soft skills they provide by Zolix is very important, and their ongoing innovation on this kind of skills help us and ensures us can have these very powerful tools for to meet the demand of this kind of expanding problems. Now we have to see the problems we are facing is becoming difficult, more and more difficult from this. So we really need the support from these reliable companies like Zolix to help us provide this kind of powerful tools. We really need it.
Yeah, thank you for your trust. And for your other research, we know you are exploring some complex system, including the multi-phase photocatalysis, and you also design some photocatalytic materials. So can you share something with us?
Yeah, I have to say multi-phase photochemical reaction is very tough, since you involve it's not like a tradition like this homogeneous or this uniphase photochemical reaction. They involve different interface, like the surface of a photocatalyst and also the gas liquid surface interface or gas solid surface. So this kind of like this kind of aspect make the problems very challenging and difficult. And but actually we have to say, comparing to as a comparison to this homogeneous system, actually this kind of a multi-phase system sometimes they show advantages over this homogeneous system, since they involve they utilize this interface. So we need to so now we have to say we need some skills, and we need some like research methodologies to figure out how this interface are involved and how we could utilize the interface rather than we waste our energy or waste our reactions on this interface. It's very challenging and difficult, but it's worth investigation.
Yeah, so in this dynamic design, how about the stability and the lifespan of the photoelectrochemical materials?
Okay. First, let's focus on the stability. That's kind of a tough question. Normally, we might underestimate the complexity of this stability. When we see you need you design a catalyst and how stable it is, but actually the stability can be divided into like the stability to the environment and the stability to the working condition. You are doing a photochemical reaction, so how stable your catalyst it is, the resistance of a light, that's very important. Sometimes there is a controversial between the stability and activity. You need some stable stuff, but sometimes stable stuff means that it's inert, so it cannot be so active to
really.
So you need a balance. How to manage the balance? So you need to dig out what's the fundamental photophysics or fundamental principles behind that, so then you can have an idea how to manipulate this process.
Yeah, thank you. So this year is 25th anniversary of our Zolix instrument. Would you please send some blessings to us?
Yeah, here I want to say, Zolix, you are very a nice partner since even when I was a PhD student, I have witnessed the fast development of Zolix, and I gain a lot from Zolix for my personal research. So keep moving and happy birthday, Zolix.
Thank you, Professor Ye. So I think we will keep moving with your wishes. Thank you, Professor Ye.
Thank
you
you
again.